In the given figure, ABCD and AEFG are the squares. Here is the given figure for that. So ABCD and AEFG are the squares. We have to prove that AF upon AG is equal to AC upon AD. And the second condition is triangle ACF similar to triangle ADG. We have to prove these two conditions. Now let us start the question here. First, the given part, that is ABCD and AEFG are the squares. This is actually given in the question. Now RTP, what do we have to prove? We have to prove two conditions. That is, first one is AF upon AG equal to AC upon AD. And the second condition is triangle ACF similar to triangle ADG. These two we have to prove. Now let us start the proof for this. And initially we will prove this condition. The first one, that is AF upon AG equal to AC upon AD. Now to prove this condition, we already know that in a square, the length of the diagonal is equal to root 2 times its side, right? So length of the diagonal is equal to root 2 times its side. Now this condition we will use in these two of these squares. So let us suppose if you take a square AEFG, okay, so if you take a square AEFG, in a square AEFG, so AF acts as a diagonal, right? So we can write AF is equal to root 2 times AG. So of course it is not only AG, we can take even GF, EF or AE, right? Since that is related to this part, we took it as root 2, that is root 2 times of AG, right? Next, from here, if you take this AG to the other side, you will get as AF upon AG equal to root 2. Let us name this as equation 1. Now similarly, as you took for the case of AEFG, similarly we will take for this for the square ABCD also. So now in the square ABCD, AC is the diagonal, right? So we can write in the similar way as AC is equal to root 2 times AD, right? So in that case, again the same similar way how you got the previous one, we can, when you take the AD to left side, you will get it as AC upon AD equal to root 2. So let us name this as equation 2. So you can see from first and second equation, since RHS is same, we can equate LHS. So from 1 and 2, we will get as AF upon AG equal to AC upon AD. This is what you have to prove. So first condition is done, right? Now we will move on to the second scenario. So we have to prove triangle ACF similar to triangle ADG. Now when we have to prove this ACF similar to triangle ADG, now we are going to use one important scenario in a square, right? So that is, if you see, every angle of a square is 90 degrees. Now when you draw a diagonal, right, the diagonal bisects that angle of 90 into 2 equal halves, that is 45 each. That scenario we will use right now, right? So that a diagonal of a square bisects its interior 90 degrees angle into 2 equal 45 degrees. Now entire things what you are going to prove under triangle ACF and triangle ADG, to prove these two as similar, now we will be taking the triangles which are beside this diagonal AC. That means on the either side of the diagonal AC, one towards AFE in that scenario and one towards DAG. So everything will be rotating here itself. Now let us try to work out on this. Now in the similar scenario, as I told you, a diagonal of a square bisects its interior 90 degrees angle into 2 equal 45 degrees. Now let us start the same part with a square ABCD. So in a square ABCD, angle A is 90 degrees. Since angle A is 90 degrees, so AC acts as a diagonal. So according to this property, I can write as angle DAC is equal to angle CAB equal to 45 degrees, right? AC is the diagonal. So according to this property, I got this in a scenario, that is angle DAC equal to angle CAB equal to 45 degrees. Now let us move on to the next square. We do have a square something like AEFG. Now in a square AEFG, as AF is a diagonal, and of course angle A is also 90 degrees there, right? Angle A is 90 degrees. So in that case, GAF is equal to FAE equal to 45 degrees, right? So I hope up to here this part is clear. Now if you observe these two equations, that is angle DAC equal to angle CAB equal to 45 degrees and angle GAF is equal to angle FAE is equal to 45 degrees. Now in this case, from these two you can write directly that angle GAF is equal to angle FAE is equal to angle DAC is equal to angle CAB, all the four angles, because all are equal to 45 degrees itself. So we will take the thing which is required. So that is angle GAF and CAB. This is what is required present for now. So we will take, because since these four angles are equal to 45 each, so I will take the scenario as, therefore angle GAF is equal to angle CAB. Okay. So let us name this as equation 3. Please remember this equation, these are very much useful for us. So angle GAF is equal to angle CAB. GAF and CAB we got here up to this part. Now moving further, here you can see some colors. So that is what is the main thing we require. If you concentrate correctly, BAF angle and CAF. If you see correctly here, CAB is a combination of two parts. CAB is a combination of BAF and CAF, right? So CAB we took it as 45 degrees. So CAB is a combination of two angles, CAF and BAF. So since CAB is 45, so therefore I will write as angle BAF and angle CAF is 45 degrees. Now from here, if I take this angle CAF to RHS, I will be left with angle BAF is equal to 45 degrees minus angle CAF, right? This is what I am left with. So let us name this as equation number 4. Now similarly, one more scenario we will apply. GAF is also 45, right? Because AF is a diagonal, angle A is 90. So previously we got it as angle GAF and angle FA is 45 each. So therefore now GAF, let me take this GAF. Now GAF is also a combination of two angles. GAF is a combination of GAC and CAF, right? So therefore GAF is equal to GAC plus CAF, right? I hope this part is clear up to here. Now next, from here, if I want to take GAC, so what do I get now? GAC is equal to GAF, this CAF which is there on RHS goes to LHS, that becomes negative of CAF, that is equal to, as we already discussed, GAF is 45. So therefore it is 45 minus angle CAF, right? So I hope this step is clear. So finally what you got right now, GAC is equal to 45 degrees minus angle CAF. So let us name this as equation number 5. Now if you concentrate correctly on 4 and 5 equations. So 4 we have angle BAF is equal to 45 degrees minus angle CAF, and 5 we have GAC, angle GAC is equal to 45 degrees minus angle CAF, right? So from 4 and 5, so from 4 and 5, since you can see RHS is same, we can equate LHS. So what do we get now? We get it as angle BAF is equal to angle GAC. This is one of the important step here. BAF is equal to GAC. This is one of the important step. You remember, let us name this as equation number 6. This is our equation number 6. Now, moving forward, again, we will be considering two scenarios again. Diagonal, we just concentrate on this diagonal AC. Okay. So when we concentrate on the diagonal AC, as I told you, DAC is completely 45 and CAB is 45, right? So DAC, when you see this DAC, we have two combinations, DAG and GAC, right? So what do I write now? In this DAC concept, if you see, angle DAC is equal to, that is 45 is a combination of two parts, that is DAG and GAC. So that is what I got step right now. DAG plus GAC is equal to 45 degrees, right? So obviously we know that DAC and CAB is 45. Both are 45 each. And CAB, we got previously, it is a combination of two angles, BAF and CAF. BAF and CAF, right? So now what do I do here is, since CAB is 45 and CAB can also be written as BAF and CAF. So in the place of this 45, I will write BAF plus CAF, right? So therefore the step becomes angle DAG plus angle GAC is equal to BAF plus CAF. Just concentrate clearly, it is very easy, just concentrate correctly. Now previous step only, we got one condition. What is the condition we got it? That is in the equation 6, if you observe clearly, we got angle BAF is equal to angle GAC in our sixth equation. So that is what we will do here. In the place of this BAF, I will write GAC, right? See, since angle BAF plus angle CAF is equal to 45 degrees. This is the combination, we know it as we explained previously. Since it is 45, so instead of this 45, I wrote this step, right? Next, now as BAF is equal to angle GAC according to that sixth equation, so I will write here as, hence angle DAG plus in the place of this GAC, I will write BAF is equal to, I have the same step again, BAF plus CAF. So just what I had done is, in this step, in the place of this GAC, I wrote BAF. Only that is the thing that I had done. So either sides BAF gets cancelled. So what I am left with right now? So I am left with, therefore, DAG is equal to CAF, right? So this is what I am left with, DAG is equal to CAF. So let us name this as equation number 7. Now this is what I require, because I have to take two triangles that I have to prove similar, and this plays an important role. Now when we go to the next step, we will understand this part easily. So now from triangles ACF and ADG, triangle ACF and triangle ADG, let us take it separately right now. This was our ACF triangle and this ADG triangle, okay. So in the previous figures, if you see, this was how they were related. Now what do we got? What we got in the first case, what we proved, that we got it as AF upon AG is equal to AC upon AD, we got, right? We got in the first scenario AF upon AG is equal to AC upon AD. Now I got two sides proportions. Now if I get that included angle equal, then I can tell that by using SA similarity, two triangles are similar. That is what I got just now. What I got right now, I got DAG is equal to CAF. Just we proved it recently. That is our equation number 7. So you can see here AF upon AG equal to AC upon AD, and also DAG is equal to angle CAF, right? So finally, by SAS similarity, we can tell that triangle ACF is similar to triangle ADG. So this is what is our complete question what we have right now. I hope you got this question here. Thank you.